Welcome to Ask and Learn.
Hi there. So for this problem, we need to calculate the volume common to these two spheres. So one convenient way to set these two spheres is to make that the center of each of the spheres is as the distance r over 2 from 0, so that we obtain this picture. And with that said, we can notice that from symmetry, the volume of A about the x-axis that we are going to call B minus equals to the volume of B rotated about the x-axis. We call this the x-axis, and we are going to call it B plus, this one that is in red. And so the total volume that we are going to obtain is just the sum of these two and this, and since they are the same, we obtain this. So we just simply need to obtain B plus so that we can determine the net volume. So to calculate B plus, we use the this method. And the endpoints in this case is very easily because the point starts in here in 0 and ends at a distance r over 2, so that those endpoints are a equal to 0 and b equal to r over 2. And from the equation of the red circle, we know that the equation for a circle, in this case, the blue one, should be as the following. It is x plus r over 2 squared plus y squared, and this should be equal to the radius of the circle, that it is simply r to the square. From this, we can solve for y. So we are going to obtain y squared is equal to r squared minus x plus r over 2 squared. And with this, we can simply obtain the volume B plus, because it is defined as the integral from 0 to r over 2. Those are the endpoints that we set in here. And this should be the integral of the area. In this case is p times y squared, and we are integrated by delta x because we have set the endpoints in that component. So with that, we substitute what we have obtained in here from the y part. So we will have 0 for r over 2 pi r squared minus x plus r over 2. Remember that r is just a constant, is the radius of the circle, and it is not changed. The only variable in here is x. So we can expand this. So we will have the following: 0 over over time. This will be r squared minus x squared plus, minus x times r when we do this cross term, minus r squared over 4. Okay, so this is what we have obtained, and this integral is in x. So from here we can see that the first term is just, when we integrate, it is pi x minus the integral of the x squared is x cubed over 3. The integral of x is x squared over 2 times r because it is a constant. And the final one is just a constant, so it should be r x over 4. So this evaluated from 0 to r over 2. So when we have done this, we can simply substitute that. So in here we will have x. So we know that for 0, we know that when we evaluate an integral is the upper limit minus the upper function evaluated in the function evaluated in the upper limit minus the function evaluated in the lower limit. And the lower limit is 0, and we can see in here that all of these terms carry an x, so that term, it will be 0, so we only evaluate for r over 2, so that will be r over 2 in this case minus 1 over 3. R over 3 is cube minus r over 2 squared. R over 2 minus r squared over 4 r squared. So with all of this, we can just simply obtain that, summing all of this, we are going to obtain that the volume is 5 pi r cubed over 24. And since we know the radius for, so we are given that the radius of the circle is just r, so we're going to spread it like that. And we know that finally the total volume is 2 times the volume that we have obtained. So that will be 2 times 5 pi cubed over 24. So this is 5 pi r cubed over 12. And this is the total volume of the common volume between these two circles. So for this problem, this is the result. Thank you.